If you are in my class and you haven't done the opener yet, stop here and go back and do the opener. Here we show 4 examples of distributive property or FOIL method, first, outer, inner, last. Take a look at what happened with A and C. In both of these, the middle terms canceled out. If you look at the terms within the parentheses here, notice that they're exactly the same, but with different signs in the middle. Same with letter C, X and X, 5 and 5, but they have different signs. This, we're going to find out, is called a difference of squares. We know that something is a difference of squares when we see a perfect square minus a perfect square. Remember, when you're factoring, you're unmultiplying. You're trying to figure out what 2 or more things multiplied together to give me the polynomial that I was given. So here, when we're looking at a difference of squares is going to always factor into 2 factors, where the first and the last terms of each factor are exactly the same, but the signs in the middle are different. We find this A and B by taking the square root of whatever we were given. Your perfect squares are a number times itself. So the most common ones that we see are 1 through 12. So 1 times itself is 1, 2 times itself is 4, and so on. Also, any variable raised to an even exponent is a perfect square. Just like this x squared minus 9, we see a perfect square minus a perfect square. So this is going to factor into 2 factors, where the first term's the square root of x squared, so x times itself is x squared. We also know that a difference of squares factors to have different signs in each factor. Then lastly, we'll take the square root of that second term. So 3 times itself is 9. So the square root of 9 is 3. If you were to multiply these back together, think about it. X times x is x squared, x times 3 is positive 3x, negative 3 times x is negative 3x. Those middle terms are going to cancel out. And because we have different signs, that negative 3 times positive 3 is going to give us that minus 9 that we started with. In this next example, we see 25x squared minus 16y squared. 25 is a perfect square, and so is 16. Both of these variables have even exponents, so they are also perfect squares. So because we have a perfect square minus a perfect square, we can factor these like a difference of squares. I'm going to start off with 2 sets of parentheses for my factors, a minus sign and a plus sign for my different signs. And now I'll take the square root of 25, which is 5, because 5 times itself is 25. The square root of x squared, which is x, because x times x is x squared. And the square root of 16, which is 4. The square root of y squared, which is y. If you were to multiply these back together using distributive property or FOIL, you would notice that the 2 middle terms would cancel out. Now it's time to look at a couple of examples. Pause the video here, try these 2, and come back when you're done. I ate and I ate and I ate some more. 8 times 8 is 64. Here you should have gotten the square root of x squared is x, so that is the same term in the beginning and the same term at the end. Remember your different signs, and then the square root of 64 is 8. Here, 11 times itself is 121. X squared times itself is x to the 4th. 9 times itself is 81, and x times itself is x squared. I also probably should have taken a GCF out of that one, but we'll worry about that later. I want to go ahead and go back and look at the opener examples B and D. And I want you to look at the middle term and the last term. Notice that after multiplying, the sign in the middle is positive, and it came from adding negative 2x plus 3x. It is not a coincidence that the 3 that is bigger than 2 is positive here, and that our middle term is also positive. At the end, we have a negative 6 because we multiplied different signs. A positive times a negative is a negative. In example D, when you look at your middle term, that middle term came from adding 2 negative numbers together. Notice how the 2 numbers that are in each of those factors above are also both negative. So when we multiplied those 2 numbers together, they gave us a positive 40. So this is not coincidence, and we're going to take a look at the rules for this. So this method of factoring only works when you have a quadratic trinomial in the form of ax squared plus bx plus c, where the a value is 1. So you won't see a number in front of the x squared. You want to think to yourself, what are the factors of the last term that add up to the middle term? So I'm going to analyze these signs a little bit. So this plus sign at the end comes from multiplying two numbers together. There's a little song that goes, when you're multiplying, same signs positive, different signs negative, yeah. So if I have a plus sign, that means I had to multiply the same signs together. So here I'm going to start off my two groups with x plus and x plus. I'm going to go ahead and list the factors of my last term, and I'm going to list them all. 1 times 8 and 2 times 4. This is going to help you when those numbers start to get bigger. Here you want to find the two factors that add up to your middle term, and that's it. You factored this quadratic trinomial with an a value of 1. In this next example, we see another plus sign at the end, which tells me that these two factors have the same signs. But now the middle term tells me that they're both negative. So when I start off these two factors, I'm going to write x minus and x minus. I'll list the factors of my last term. So -1 times -10, -2 times -5, and find the ones that add up to -7, my middle term. I can always check these by multiplying them back out and using distributive property or FOIL. So if plus signs at the end tell me that I have the same signs, minus signs at the end tell me that those factors were different signs because different signs negative. The middle symbol here is going to tell me which sign my bigger factor is. So here, whichever factors I list out, I'm going to make every bigger factor positive and every smaller factor negative because they need to be different signs. So -9 is 1 times 9 or 3 times 3. I'm making that bigger factor positive and the smaller factor negative. Now I'll see which ones add up to the middle term, which is -1 and +9, and I'll write my factors that way, x minus 1 and x plus 9. So now we've seen examples where both factors are positive, both factors are negative, or the bigger factor is positive and the smaller factor is negative. Now we're going to see where our bigger factor is negative and our smaller factor is positive. So I'm listing out those factors of -15, and here I'm giving the bigger factor the negative because my middle term is negative. Remember, you want these factors to multiply together to give you the last term, but add together to give you the middle term. So when you try these 4 examples, take a look at the last term and look at the sign. That's going to tell you whether they have the same signs, they're both positive, the same signs, they're both negative, different signs and the bigger one's positive, or different signs and the bigger one is negative. Pause the video here, try these, and come back when you're done. So when you look at this first example for this you try and you list the factors of the last term 16, you find that 2 times 8 is 16 and 2 plus 8 is positive 10. In this second you try, we have a -4 times a -7 is a positive 28, but -4 plus -7 is our -11 in the middle. Then we have this big -72 with all these factors, but we find that -8 plus 9 is what's going to give us that positive 1 in the middle. But if you remember that trick to give the bigger factor the sign of the middle term, that will help you out a lot. Same thing here, you've got a -20, so they are different signs, but the bigger factor here is negative. So we find that that +4 plus -5 is what gives us that -1 in the middle. Thanks for coming. Have a great day, and we'll see you next time.